What's up everyone, this is Carlos, and in this video I'm going to solve the problem perfect root from Codeforces. Here's what it says. A positive integer x is a perfect root if there exists an integer y such that the square root of y is equal to x. For example, 5 is a perfect root because the square root of 25 is equal to 5. For each test case, output n distinct perfect roots. Note that the values only need to be distinct within each test case. You can use the same value in different test cases. Input. The first line of the input contains a single integer t. t These values is between 1 and 20 inclusive, which is the number of test cases. The only line of each test case contains an integer n, which is likewise between 1 and 20 inclusive, which is the number of perfect roots to output. Output. For each test case, output n distinct perfect roots. Each perfect root x must be in the range between 1 and whatever this number is. Okay, so let's see of the nodes. Let's see the first input. So let's say we have three test cases and we get how many perfect roots? Yeah, how many distinct perfect roots we have to output for each of the three test cases. For the first one, it's 1, 2, and 5. Okay, so here we can say that for the first input, sorry, for the first test case, we can use output 1, then 2, 2 and 4. Okay, so this makes sense. So this problem really comes down to outputting and distinct integers for each test case. And to understand why, it's because they are asking us to output and distinct perfect roots. And if you think about it, really any integer can be a perfect square root. Sorry, yeah, sorry, a perfect root. Because let's say you start from 1 and you say 1 times 1 is 1 and you get the square root of 1, which is 1. Likewise with 2, you can get 2, sorry, you can do 2 times 2, which equals 4. And as such, if you want to calculate the square root of 4, will be 2. And you can do this for literally any integer, take 10, take 100, 127, you name it. So in order to solve this, what I'm going to do is uh, we just have to find a way to generate n distinct integers for each of the test cases. And I'm just going to do this very simply, which is I'm just going to take how many integers we need, and then uh, I'm just going to loop from 1 up until n and call it a day. And to understand exactly why, I'm just going to show you. So let's say the first thing we have to do is take the number of test cases. So for that, we can do something like int t. Okay, so that will be our number of test cases first and foremost, and then we're going to be iterating um, for this amount of times, for this many times. So what will we do exactly inside this while loop? Well, we're going to take and we're going to take t integers or t lines, each one containing how many integers we need for that specific test case. So let's say we could do something like int n, and then in each iteration we can just take the n, and here's where the solution comes in. And again, this is just one way to do it. Let's say you can do a good old for loop and you do something like this, for example, and you say from 1 up until n, we're just gonna keep increasing. And sorry, I'm getting used to this keyboard. And here I'm just going to output each value of I. And we don't want to close the line just yet or end the line. We're just going to add a space. And then once we are done with all the integers we need for this test case, we're just going to end the line right here in order to preserve the desired output. Um, sorry, the desired output format. And in this case, I think we would be done because why don't I just show you? So let's say this is compiling and we can do something like this right here. We paste it and there you go. We have 3 lines and each line has n distinct integers, which by definition, or I don't know if by definition is the correct term, but whatever, which by what I just explained earlier, fulfill the conditions that this problem explains or poses. So, and that would be it. Let's see if this passes. Let me submit the code right here. It's verifying if I'm human. Okay, let's see. And it is accepted. Now, in terms of uh, big O notation or time complexity, as you can see, this would be O of n because we would have to iterate over um, how many test cases we would need. And this for loop for this time for this problem in particular would be 20 at most because that's how many integers we would need at most for each test case. So yeah, I think we would leave it at O of n. So that's it. I hope that helps you.